Alright, Algebra 1. So here is your Unit 2 review. I'm going to go through all of these problems. So again, like always, if you need to pause, rewind, anything like that, feel free to do that. And if you have any additional questions, just let me know. So here we go. First problem, we need to simplify. So this is being added, which basically just means that we can ignore the parentheses and just jump right into combining our like terms. So what I'm going to do is I'm just going to get rid of the parentheses and then go ahead and do that. So first of all, starting with your highest power, I have an x to the third. So I can combine 3x to the third. Don't forget to take the sign that's in front of the term that goes with it, plus 5x to the third. So we add those together and we will get 8x to the third. Then we go down to our x squared. Well, this x squared right here is the only x squared term, so I'm just going to bring that down, minus 4x squared. Then we go to our x terms, and again, I have this x term right here, and that is the only x term, so I will bring that one down. That doesn't have anything to combine with it. And the last one, I have -1 or a -1 plus 12 for my last term that has no variables, which is 11. So that is your final answer there for number 1. Number 2 is very similar. The only difference here is we have a negative, so we need to change all these signs. Again, it will not change your first set of parentheses, so I'm going to go ahead and just recopy that. But then all of these will change. Right now this is a positive 4, so we're going to make that a -4, x to the fourth. This is a -2, so I'm going to go ahead and make that a positive 2, x squared. And this is a positive 8, so multiply by -1, and you get -8. And this is basically just your distributive property. That's really all we are doing here, is taking a -1 and multiplying it through, but all that does is change our signs. So now we will add our like terms. So let's start with our x to the fourth, -2x to the fourth, minus 4x to the fourth. Again, all we're doing is adding the numbers out front. We are not doing anything with our exponent. That happens when we multiply, which we'll see later on. But for now, all we're doing is adding the numbers out front. -2 minus 4 is a -6, x to the fourth. Up next, x squared. I have an x squared right here, plus positive 6x to the fourth, and right here a positive 2x squared. I think I said 6x to the fourth. I'm sorry, that's supposed to be 6x squared. And a plus 2x squared. Again, add the numbers out front. 6 plus 2, that gives me an 8x squared. We're not changing the variable's exponent at all, okay? When you're adding or subtracting, all you're doing is adding or subtracting the numbers out front. Next, the x terms. We got a -x. No other x terms to combine with it, so I'm going to bring that one down. And our number with no variable, -8. Again, nothing to combine with that, so -8. Okay, and again, 1 and 2, very similar type problems. Yeah, that's basically it right there. The only thing you have to look out for is if there is a negative in between, change all your signs and then add them together. That's it. Okay, so now we're getting into our multiplying. This is where the exponents will change. Okay, when we're multiplying, this is where our exponents will change. And again, look at this keyword here, simplify completely. Sometimes we will end up with like terms that we need to add together, just like we did here in these problems, and sometimes we won't. So just be cautious of that for your final answer. Just make sure it's completely simplified. So 3x times 4x cubed. Multiply your numbers. 3 times 4 is 12. Add your exponents. This is a 1, so 1 plus 3 is x to the fourth. Keep going. 3x times -6x. Multiply your numbers. 3 times -6 is -18. Add your exponents. Again, this has a 1, so 1 plus 1 is x to the second. Last step, 3x times 1. And if you remember from a while ago, like, I don't know, 3rd grade or something like that, anytime you multiply something by 1, you just get itself. Like 5 times 1 is 5, 4 times 1 is 4, -10 times 1 is -10. So if we have 3x times 1, we're just going to get a 3x. But again, 3 times 1 is 3. X to the first, there's no x here, so we're just left with x to the first. So that's our final answer for number 3. No like terms to combine it. Remember, like terms have the same variable but also have the same exponent, which we do not have right here. All right, next. This one will require our distributive property to happen twice. So multiply 2x through. 2x times 7x. 2 times 7 is 14. X times x is x squared. 2x times, don't forget the negative 4, is negative 8x. Up next, we're going to multiply this 5 through. So 5 times 7x. 5 times 7 is 35x. And 5 times negative 4 is negative 20. Next step, this is where the simplify completely comes into play because these two terms here in the middle are like terms that need to be combined together. So we will do that. But first of all, let's bring down the 14x squared. There's nothing to combine with that, so we're just going to bring that guy right down. Negative 8 plus 35, add those together. Use your calculator. Negative 8 plus 35 is 27x. And this negative 20 out here has nothing to combine with it, so we're going to bring that guy down too. And there's your final answer. Last one, this one is the one that's going to have the most steps. And again, we're going to take our numbers just like we did in that last problem and multiply it through. So we're going to have the distributive property happening twice. 2x times 5x, multiply your numbers. 2 times 5 is 10. X times x squared, again we're adding the exponents. There's a 1 here even though it's not written. 1 plus 2 is 3, so x to the third. Keep it going here. 2x times 3x, multiply your numbers. 2 times 3 is 6. X times x is x squared. Good. And last one here, 2x times negative 9. Take the 2 times the negative 9. You can break out your calculator for that if you want to. 2 times negative 9 is negative 18. X times, there's no x here, so that's just an x. All right, now when we do this one, again, it's not a 1, it's a negative 1. So negative 1 times 5 is a negative 5, and there's no x with the 1, so whatever these x terms are, they're just going to be brought down. So x squared, negative 5x squared. Negative 1 times 3x is a negative 3, and then again we're bringing the x down. And the last one, negative 1 times 9. Negative times negative is positive. 1 times 9 is 9. But again, we are not finished here because we have some like terms. So I see I have an x squared right here, and I have an x squared right here. I also have, actually let me write this out. So first of all, 10x to the third, I don't have anything to combine with that, so I'm going to bring that down. Now I have some x squareds. 6x squared minus 5x squared is 1x squared, so we just write that as x squared. There is a 1 here, but you don't have to write that. And then negative 18 minus 3. Negative 18 minus 3 is a negative 21x. And then we have the plus 9. So again, in the first step when we multiplied, that's where the exponents changed. But in the second step where we added them, the exponents don't change, it's just the numbers out front. So again, keep that in mind there because we had a couple things happening. All right, next, factoring. Now we're getting into our factoring part, which is basically just doing what we just did there, only opposite. Okay, so we're just working backwards. So let's look at our numbers here and see what number can I factor from this. And actually, now that I'm looking at this one, this is one that we had done previously, like in an earlier set of notes that we don't do anymore. This was actually a factor by grouping where we would look at this set of numbers and this set of numbers, and we actually skipped over that set this year. So this does not have anything that can factor out of everything. Like I could take a 3 out of these two and a 2 out of these two, but you see there's no number and no variable we could take out of all of these. So if we can't do that, that means it's prime. So this one here would be prime for what we did, okay? So you don't need to worry about that one. We won't see that on the test. This one, though, we can look at and factor some numbers out. So the biggest number we can take out of 10, 15, and 35 is 5. And how many x's can I take out? Well, I'm looking for my smallest power. So right here is an x to the first. So my smallest power of x is just x. And then my smallest power for y, I have a 3, a 2, and a 3. So smallest power is 2. But again, we want to factor it, not just find the GCF. We actually want to factor this out. So let's divide. 10 divided by 5 is 2. I started with x squared, which means there were 2 copies of x. I took one of them out, so there's still one left here. Y to the third meant 3 copies. I took 2 of them out, so there is still one left. Minus, next step, 15 divided by 5 is 3. I started with x squared, but I took one of them out, so I'm still left with one of them. And I started with a y squared, but I took a y squared out, so there are no y's left in that term. Last term, 35 divided by 5 is 7. I started with an x, but I took that x out, so there's no x's left here. And I started with a y to the third, and I took 2 of those y's out, so there is one y left. And that is your final answer. Next, first thing we always look for is a GCF, okay? So we're going to look for a greatest common factor, and then we look for the difference of 2 squares, and then if it's none of those, that means it has to be a trinomial. Okay, so GCF, is there some number or variable we can take out of both of these? No, so that one is out. Is this a difference of 2 squares? Well, it's a difference. There's a minus sign. There's 2 terms. Are they both perfect squares? Well, x squared is a perfect square. Is 81 a perfect square? Think about it. Can I write 81 as some number times itself? Yes, we can. That's 9 times 9. So we can jump right to our answer here. 2 sets of parentheses. And we say, well, we have to get x squared, so that comes from x times x. 81, again, we can get 81 maybe a couple different ways, like 3 and 27 or something like that, but we want this to be the same number. So 9 and 9. Okay, so what number times itself is 81? That's 9. One's a positive, one's a negative, and that is your final answer right there. Okay, so this was not a trinomial. If you remember, a trinomial means 3, which means there would have to be 3 terms, and that's actually, I put that in a separate section here. So next one, number 9. First of all, is this a GCF? Do we have a number we can take out? Well, 16 and 49, there is no number we can take out of both of those. Can I take a variable out? Well, this has n squared, but this doesn't have any n's, so no GCF. So then I ask myself, is this dots? Is it difference of 2 squares? Well, it's a difference. I have 2 terms. Are they all perfect squares? Can I write 16 as some number times itself? Yeah, it's 4 times 4. N squared is n times n. How about 49? 49. Yeah, 49, we can write that as 7 times 7. So we are ready to write our 2 sets of parentheses and split this up. So again, for our first term here, 16n squared, we know we're going to have an n in both of them, but we also need the number that multiplies by itself to get 16. So that's a 4. So they both start with a 4, and then with the n squared, they both also get an n. One's a positive and one's a negative. It doesn't matter which one. I'll mix them up for this one just to show you that it doesn't matter. And then 49 is 7 times 7. So that is your final answer there for number 9. That is completely factored. All right, now we are getting into this trinomial stuff, okay? So instead of saying, is it a GCF? Well, we're still going to start with that, but we can skip over this difference of 2 squares because that means there has to be 2 terms. You see here we have 1, 2, 3 terms. So it can't be difference of 2 squares if it has more than 2 terms. So then we will jump into our trinomial. Oops, trinomial. There we go. Which means when we do this, we set up our table. Okay, so we will set up a table for this one. There is no GCF. There's no number or variable we can take out, so GCF is gone. I didn't want to do that. Sorry, I wanted to cross it out. GCF is gone. Difference of two squares is gone. So the trinomial means I need to set up a table, which means I'm looking for two numbers that will multiply to give me 27 and add to give me negative 12. Okay, so multiply to get 27, add to get negative 12. Now, if we're multiplying to get a positive number, that means our signs have to match, either both positive or both negative. And the way that we know whether they're both positive or both negative is by looking at the middle sign. Since that's a negative, we know we're going to make these all negative. So you could do like negative 1 times negative 27, but if we add those together, we are not going to get negative 12, we're going to get negative 28. So that one's out. We can cross that one out. Next, negative 3 times negative 9. Well, what is negative 3 plus negative 9? Use your calculator. That's a negative 12. So since we got our answer right there, we know that this is correct. We don't have to try anymore. There aren't any more to try anyway because 27 only has those two sets. But we're now ready to write this in our factored form. So two sets of parentheses. How do we get x squared? Well, again, same way from dots. X times x. But now instead of like one's a plus, one's a minus and doing all that, we look at our table to see our other terms. We had a minus 3, so minus 3. We had a minus 9, so minus 9. That's it. There's your final answer. All right, number 11. Again, we look for a GCF first, and we do not have a greatest common factor here. There's no number we can take out, no variable we can take out. So we go right to our table. So I need two numbers that will multiply to give me negative 35. Oops, that was a bad line. Multiply to give me negative 35. There we go, that's better. And add to give me 2. So if you think about the numbers that will multiply to give you negative 35, remember one of them has to be positive and one has to be negative. We look to our middle sign. Since this is a positive 2, that means the bigger number needs to be positive. So when I see a number that ends in 5, I think of 5. So negative 5 times 7 gives us negative 35, and then negative 5 plus 7 gives us 2. So that is our correct answer. We are ready to put this back in factored form. So two sets of parentheses. They're both going to start with an x. And then one will start with a negative 5, so minus 5. The other one is a positive 7, so plus 7. And that is your final answer for number 11. Okay, number 12. Again, first question you want to ask yourself, do I have a greatest common factor? Do I have a number that I can divide out of all of these? And yes, we do. We can take a 3 out. So I'm left with x squared minus 3 divided by 3 is 1, so 1x. 36 divided by 3 is 12. Next, this is a trinomial, so we set up our table. So negative 12 and negative 1. Now, we're trying to multiply two numbers to get negative 12, so that means one positive and one negative. So like negative 2 times 6. Well, negative 2 plus 6 gives us 4, so that is wrong. Now, also another thing I want to point out to you is that if we know one of these signs is positive and one is negative, the way to kind of shorten up your table to make you have fewer things to try is just keep in mind that whatever your middle sign is, so over here it's a negative 3, that has to match your bigger factor. So like for example, negative 4 times 3. Why did I make it negative 4 times 3 instead of negative 3 times 4? Well, the bigger number has to match the sign of your middle number. Okay, so I can avoid trying this and failing with that one because this one will actually give me the answer that I want. Negative 4 plus 3 is negative 1. So now I'm ready to write this. X, I have a negative 4, so minus 4. And then I have a positive 3, so x plus 3. And a lot of people want to leave that as your answer, but remember, we had a 3 right here. This is still part of our solution. So that is the answer to this problem. Make sure you have that 3 out front. All right, 13, one more. Ask yourself again, is there a greatest common factor? Yes, I can take a -2 out, but also they all have an x. So the smallest exponent is just 1, so I can take an x out. So let's see what we're left with. -2 divided by -2 is 1. I started with x to the third. I took 1 out, so I'm left with x squared. Next up, -2 divided by -2 is another 1, but now it's a positive, so it's going to flip it to a positive. X squared, I started with 2 x's, I took 1 out, so there's still an x left. And then 60, positive 60 divided by -2 is -30. And then the x, took that out, so that's it for my GCF. So now I'm going to go to my table. I need two numbers that will multiply to give me -30 and add to now give me a positive 1. So when I'm looking for my factors of -30, I want the bigger number, again we're looking to match this, the bigger number should be positive. Okay, the bigger number being positive will help, like I said, it's going to help us to save some time on our table. So when we start this, like if I would have started with -6 times 5, -6 plus 5 gives us a -1. We wanted a positive 1. So it would have saved you that step right there, and if you jump right to the -5 times 6, you know, you can get to your answer quicker. You should still get the answer, but like I said, it saves you some time if you know those little things. So bring down the -2x, and then I have x minus 5 and x plus 6. Final answer, and I am finished. 14, here we go. We only have one of these problems that we need to do, but again, we're going to look at these separately. So n squared minus 4. N squared minus 4. This is a difference of two squares, so hopefully you recognize that right away. N plus 2, n minus 2. Again, we want to know what times itself gives us n squared. That's n. So n times n. What times itself gives us 2? Or I'm sorry, what times itself gives us 4? So that's 2. 2 times 2. And then one positive and one negative. On the denominator, we're going to do a table for that one. So 18 and 11. Now, we already know that one of our factors has to match one of these in order for us to cancel. Since this is an 8, since these are both positive, we know that the ones on the bottom have to be positive, so we know the n plus 2 will have to be there. It's not the n minus 2, because one of these would be negative if that was a minus. So we know it's not n minus 2. So we know one of the numbers is 2. What's the other number? 9. So 2 plus 9 gives us 11. So then we know the other factor is n plus 9. Okay, remember you can only cancel things that are exactly the same over multiplication. So here's the multiplication, and here's the multiplication. What do they have in common? N minus 2. So what am I left with? Up top, n minus 2, and on the denominator, n plus 9. And that is your final answer right there. You cannot do anything else with it. Don't be tempted to cross out the n's and say -2 over 9. That's not correct. That's canceling over a positive and negative, which you can't do. You can only cancel over a multiplication. Next, 15. 15 and 16 are both based off of this picture right here. So we're going to basically be looking for two things. One is the perimeter, and one is the area. So for the perimeter, remember, both sides are the same, 5x minus 2, and also the top and the bottom are the same, 3x plus 3. So we're going to go through and add these all up. Now, you can rewrite them, and maybe that would be better if you just rewrote, here's the top, here's the right, here's the, oops, here's the bottom, and here's the left. Sorry, I tried to change my minus sign into an x because I forgot it at first. 5x minus 2. Okay, so now add up all your x terms. So 3x plus 5x, that's 8x, plus 3x, well, I'm up to 11x, plus 5x, I'm at 16x. And then let's add up all of our numbers. So 3 minus 2, I'm at 1, plus 3, now I'm up to 4, minus 2, and I'm down to 2. Positive 2, so plus 2. Final answer. There you go. That is your perimeter. Next, number 16, for the area, okay, now we're trying to find the area of the blanket. We're just going to do length times width. So 5x minus 2 times 3x plus 3. So let's multiply those. 3x plus 3 times 5x minus 2. Okay, let's multiply these out. So 3x times 5x gives me 3 times 5 is 15. X times x is x squared. 3x times negative 2 is a negative 6x. 3 times 5x is a positive 15x. And 3 times negative 2 is negative 6. Again, like always, we have to make sure this is completely simplified, which means combining our middle terms. So 15x squared plus 9x, negative 6 plus 15 is 9, minus 6. There's your final answer for that one. Okay, so there's finding the perimeter and area when you're given a rectangle, which I know you've seen those in notes and homework and stuff like that, worksheets, so just wanted to throw another one in there. The last two are repeat problems. These are problems from older sections from chapter 1. So order of operations here, let's go through this. So I'm going to start inside my absolute values. I'm going to recopy everything else, so negative 2. Inside the absolute value, I'm going to do my exponents first. So this right here is 1. I'm just going to do one thing at a time here so you can see exactly what it is that I'm doing, and you can hopefully find any mistakes that you may have had. Okay? Next, inside the parentheses, I'm doing this. 2 times 7. So negative 2. Inside, not parentheses, sorry, absolute value is 5 plus 2 times 7 is 14 plus 1. Outside the absolute values, we got all the rest of this stuff here that I'll deal with later, but I am still working on simplifying my absolute values. Now inside here, I will add all of these together in this step. We can do all that at once. They're all being added. So 5 plus 14 is 19 plus 1 is 20. So negative 2 times 20, absolute value of 20. Recopy the rest of this, square root of 9, plus 4 divided by 1/2. Okay, next. Absolute value of 20 is just 20, so that will not change anything. 20 times negative 2 is negative 40. Now, keep in mind, the stuff in the absolute value bars will be positive, which it was. The absolute value of 20 is 20. But when you start multiplying by stuff on the outside, that no longer holds true, because we just multiplied by a negative number on the outside. That flipped it to a negative number. Okay, so just keep that in mind. I know a lot of people are going to look at that and say, well, I thought absolute values had to be positive. That's correct. But we took the absolute value of 20, made it 20, and multiplied by the negative 2, which made it a negative 40. So just keep that in mind. All right, now we're done with all that. So this negative 40 is just going to be carried along here while I work on a couple things in here. So next up, we will do we will do the square root. Remember, square roots are done the same time as exponents. Exponents have to be done before dividing. So negative 40 plus 10 square root of 9 is 3 plus 4 divided by 1/2. Now we will do our multiplication and division left to right, however they appear. So again, negative 40 is just being carried down, plus 10 times 3 is 30. And you can do both of these at the same time if you want to. Like I said, I'm just doing one thing at a time so you can see exactly what's happening here. So next up, negative 40 plus 30 plus 4 divided by 1/2 is 8. That's not 2. It's not 4 times 1/2. It's 4 divided by 1/2, so that is 8. And adding and subtracting, let's go left to right here. Negative 40 plus 30 Negative 40 plus 30 is a negative 10. Plus 8. Last step here, negative 10 plus 8 is negative 2. And we're done. Whew, that took a while. All right, lots of steps in there. Again, I broke it down one thing at a time. I wanted you to see exactly what was happening in every single step. So again, if you missed any of those things or one of those steps does not look right to you, go back, rewatch it, and make sure you understand how to do your order of operations, because it's been a little while since we've seen those. Okay, number 18. Exponents. Remember, first thing we always do is we start off by saying anything that does not have a visible power, we're going to give it a 1. So there, there, and there. And now we will multiply this exponent through. So 2 times 1 gives me 2 squared. 2 times 3 gives me x to the 6th. And then 2 times 4 gives me y to the 8th. Okay, I'm going to put that in parentheses for now. Next one over here. 3 times 1 is 3, so I have 3 to the 3rd. 3 times 1 again is 3, so I have x to the 3rd. And then 3 times 8 is 24, so I have y to the 24th. Big numbers. All right, let's deal with our numbers first, right? So let's take care of those, and then we'll work on our x's and y's. So 2 squared is 4. I'm going to recopy the rest of this. 3 to the 3rd, that's 3 times 3 is 9, times 3 is 27. X to the 3rd. Ooh, almost sneezed. And y to the 24th. All right, let's multiply these numbers out front, okay? So we're still working with our numbers before I do any of my variable stuff. So multiply 4 times 27, you get 108. And what do we do with our x's now? Well, since these are being multiplied, we add the exponents. 6 plus 3 is 9. And then y, 8 plus 24 gives you 32. So there is your final answer for this one. And again, like always, I know we threw a couple of chapter 1 stuff in there, but if any of these problems are confusing to you or you're not sure, please let me know. Send me a private comment or an email, and just let me know. But this is your review test for your test, chapter 2 test. So you know, everything from chapter 2 is in here, which I know was a lot, mainly dealing with the factoring stuff. So if you have any questions, just let me know.